This is the first video in a few in a series around looking at the topic called standard methods of solution. Standard methods of solution is a term given to a set algorithms, quite short, that a program can use to solve some quite common problems that occur when you're writing a program. So we've got a list of things here. So totaling, so entering some numbers, adding them up, or having an array with some numbers in and adding the numbers in the array. Counting, so that could be counting anything at all that the user is entering, counting the number of times the user enters the letter A, counting the number of times the user has written the word car, and that could be whether it's in an array or whether they're typing it in. Finding the maximum or largest value or largest number in an array, finding the minimum or smallest, finding the average. So the average is just our total divided by the number of items that made that total. And then we have two more, a linear search and a bubble sort, and those two won't be the focus of this particular set of videos. They'll be coming up soon. So we'll have a quick first of all look at the algorithm, and I want you to work out the output. So we've got an algorithm here. I'd like you to pause the video, spend a few minutes, work out what the output's going to be, decide which of the standard methods of solution it is, and then press play and we'll go through the answer. Okay, so with this particular video, with this particular algorithm, the first thing we're going to do is work through it step by step. That's really important. And because we've got a few things to keep track of, it's always a good idea to write those down up in the corner of your piece of paper or on your dry whiteboard. So the first thing, we have a variable here which is being assigned the value 0. So I'm going to write that at the top, count sign 0. Then we got for I is going to be 1 to 5. So I'm going to write down that I is initially going to be 1. Now we output enter a number, so that's going to form part of the answer. And we input the first number, and we've got the list of numbers here. They're given to us in the question. So the first thing we input, number we input is 7. So I'm going to write that down again because I just need to keep track of what's going on. If number is equal to 7, so that's going to give us a true or false. So number is 7, so that is true. So this will happen here. So count is going to be assigned count plus 1. So count is going to go from 0 to 1. Now we come down to our next I. Our next I is going to be 2, so that will change, and we can go around the loop again. So we'll output enter a number, we'll input the next number, which is 5 off our list there, and then we will do the comparison. Is number equal to 7? 5 is not equal to 7. This doesn't happen. So this only happens if this is true. So we come down to our end if, next I is going to go to 3. There it goes. And we will output enter a number. We'll input the next number, which is 5 again. So let's input that. There it is. Is number equal to 7? No, it's not. So we ignore this and we get to our end if. Then we go to next I is going to go to 4. So we go around again, output enter a number, we input our next number, which is 7, and then we do our comparison. Is number equal to 7? Yes, it is. That's true. So count is going to go count plus 1, so count goes up from 1 to 2. We end if next I, so I can go to 5, so we go around again, output enter a number, input the next number is 3. Is 3 equal to 7? Is number equal to 7? No, that's not true, so we ignore this part here. We come to our next I. Now I is 5. 5 is the maximum number that we can go to in our for loop, so we can't increase the I, so that means our loop will stop. So we go to the next line, which is output count, so that gives us 2. Okay, so we couldn't use the last number that was given to us because our loop has stopped, so that's fine. Which method of the solution is this? So I think it's fairly clear, particularly from the algorithm, that we're counting. We're counting the number of times that 7 appears. Okay, for the next algorithm, we have got our algorithm here. There's a few clues as to what might be going on. So again, I'd like you to work through the algorithm, write down the outputs, and then once you've done that, try and decide which of the standard method solution this is. So pause the video, have a go, and then we'll have a look at the answer. Okay, so here is the answer for this one. Now if you notice, we're setting this all to 0. I is going to go from 1 to 4, so you need to keep track of that. But inside the loop, we're outputting enter a number, we're inputting the number, so there's the numbers there. We're adding the number to the total each time, but we're actually outputting inside the loop. And I just wanted to make you aware, just in case you perhaps repeated what we did for the last one. So you put enter a number, enter a number, enter a number, enter a number, then you put the sort of total at the bottom. This time we're actually outputting inside the loop, so the total is going to be output each time. So it's really important to again work through line by line and not make any assumptions based on what you've done before. Okay, so that's really important. So maybe if you didn't get this one right, have another go at it. Which of the standard method of solution is this? Well, it's pretty clear that we are entering numbers and we're totaling the numbers as we enter them. Okay, right, let's have a look at the next one. What will be the output of the following algorithm? Again, we've got some inputs. Again, there's a few clues as to what might be going on, so pause the video, spend a bit of time, work through, write down the outputs of the algorithm, and then decide which of the standard method solution is. So just write down what the outputs will be, and then we'll have a look at the answer. Okay, so have a look at the answer to this one. You can see this time we've got two variables here. We're both assigning them both to 0, total and average. Our for loop is going to go from 1 to 4, so I is going to start off at 1. We're going to output enter a number, we input the number, and we add it to the total. So this is very similar to what we did in the last algorithm, which is not outputting anything in here. So we're working out the total. And here we've got a variable called average, and we're assigning that total divided by 4. And 4 happens to be the number of numbers that we entered, and then we're outputting the average at the end. So again, this one, what standard method solution is this? It's finding the average. So again, as a programmer, you would just automatically have this tucked away in your memory. So if you ever needed to work out an average, you would just use this particular algorithm to solve the problem. Okay, next we have different algorithm here, and we're going to do the same thing again. I'd like you to work through the algorithm step by step, and then write the answers down onto the workbook that you've got. Okay, so just the output. What's the output from the algorithm, and then decide which of the standard method solution it is. So pause the video, and then have a go, and then come back and we'll look at the answer. Okay, so this time let's work through this one. So we've got x. Not a very helpful identifier, but we're going to use it anyway. So x assigned that 0, I is going to be 1 to 5, so I is going to start off at 1. So we can output enter a number, we then input our number, so we need to keep track of whatever that number is. The first number is 7, and then we're going to say if number is greater than x. Now x is 0 and the number that we have is 7, so that's going to give us a true. So that means then that we're going to make x whatever the number is. So the number was 7, so x is going to go, there's our true, so x is going to go to 7. We now go to our next I, so I is going to go to 2, so we're going to go around again, output enter a number, input the next number, so the next number is 3. Is the number bigger than x? So is 3 bigger than 7? Well, it's not. So this won't happen. So we come down again to our next I, so there's our false there. Our next I is 3, so we go around again, output enter a number, input our next number is 9. Is num greater than x? Is 9 bigger than 7? Well, that is true. So that means now x is going to become whatever num is, happens to be 9. Okay, and if you notice, each time the number entered is bigger than x. It's replacing x. Let's have a look what happens next time. So next I is going to go to 4. We go around again. We output enter a number. We input our next number. That's 5. Is 5 bigger than x? Is 5 bigger than 9? No, it's not. So we come down again and we go to our next I, which is 5. Output enter a number. Input our next number, which is 1. Is num bigger than x? Is 1 bigger than 9? No, it's not. Okay, there's our variables there, so we don't do that. We then come down to the next I. We can't go to another I because we're at 5, and that's the biggest we can get to, so we have to stop and drop out of the loop. There's our false there, which means we just output x, which is 9. Okay, have a think, which of the standard methods of solution is that? Okay, and yeah, we found the biggest number. So what I'd like you to do here is the algorithm. Can you just rewrite that algorithm and just make sure we're using meaningful, helpful identifiers? Okay, so let's have a look at the answer. So hopefully you've paused it. We'll have a look at the answer. So we just need to replace x with something that suggests that we're finding the biggest or maximum. There's also a question around I. We do write I. It's a lot shorter than writing index, which is what it stands for. But that's something we'll talk about when we're preparing for the exams next year. Okay, so there it is. And then lastly, we've got this one here. So this time, slightly different algorithm. We've got x, which we're assigning a really big number. I just want to go back to this algorithm here. Notice when we're finding the maximum number, what we do is we set the initial value of maximum to a really small number. That means that the first number input is going to become the biggest number. We can then compare that with all the others. So the general rule is, if you're trying to find the biggest number from a list, you set the maximum value to a value smaller than any of the numbers. So let's say you knew the list contained the numbers between 10 and 100. If you set max to 9, that means the very first number entered will become the maximum number. If you're not sure, you can just set it to something really small, minus 999999999, whatever. Okay, and you know it's going to be the smallest. Anyway, back to this one. So this time we're setting x to a really big number, and we're going to work through this algorithm. So this time I want you to pause the video, see if you can figure out what the outputs will be, and then we'll have a quick look at the answer. Okay, so here is the answer. So this time we're going from 1 to 5. We're outputting enter a number. We're inputting the first number, which is 7, and because 7 is smaller than 99999, we knew that would be the case. Then we're going to set x to num. So x is going to be the smallest number, which will be 7. Then we go to our next I, which is 2, and we keep going around. And you'll notice that what's happening is each time we're comparing the number that's typed in with x, and if the number they typed in is smaller, then that will become x. So we're looking at the smallest number in this list of numbers here. Okay, so hopefully you've got that, and that is indeed the algorithm to find the minimum or the smallest number. And again, similar to what we did before, I'd like you to rewrite that with some sensible identifiers, some helpful identifiers. So pause it, have a go, and then we'll come back to the answer. So yeah, so here is the answer. So this time we're looking at the minimum numbers, the smallest numbers. Okay, and I think that is the end of this little video. Thank you very much, and the next one we'll look at in a bit more detail at each of the different standard methods of solution. Thank you very much.